Okay, so I'm not going to go through all of these calculations again. I just wanted to show you what a typical spreadsheet would look like for this reaction in this lab. And again, you can make the spreadsheets however you see fit, but I think that the layout that we've done here probably works a little bit for everybody. We've broken it down into different sections, and I'll talk about each section independently. That way it's all nice and clear cut on what you want to do. All right, so up here at the top, you're seeing CTC 112, and this is the calcium carbonate titration. You're also seeing how I take points off. So significant figure errors, I'm really kind of wishy-washy on. You know, at this point, if you can just do the calculations for Christ's sake, I'm going to give you the credit. And then you take a look at the total questions. Total questions mean basically the number of data points. How many data points are you actually taking through the process, and how many calculations are you doing? So there's a total of 118, which is the way that this is laid out. So that gives you a points each, about 0.84. Every time you miss a number, every time that you don't do a calculation the right way, that's 0.84 points for every single thing that you miss. So up here at the very top is part A, hydrochloric acid standardization. So you're seeing that there's 3 rounds of them. So they pipetted 5 milliliters of hydrochloric acid in the beginning of this experiment. And then this is the sodium hydroxide that was loaded up in the burette. So they started with 0.09 mils. They didn't quite fill it up to the 0 mark. So they read the actual volume that was on the burette, and that ended at 7.13 mils. So that titration took 7 milliliters, give or take a little bit. Round number 2 and round number 3, you're seeing about the same amount of volume, right? It started off at 7.13. It went 14.2 before I got a color change. So the difference in those volumes is how many milliliters of NaOH that it took. And then finally, line number 3 was the same way. It started at 14.2. It ended at 21.3. The difference here is the number of milliliters of NaOH that it took. My molarity of NaOH was given to me, so 0.1052 is what was reported. So I calculate the molarity of hydrochloric acid. So just like we talked about in the calculation portion, I want to reference the cells that I need to use in order to make this calculation work. I want Excel to do the calculation for me. So if you look at the cells up here at the top, I'm going to take J5, which is the molarity of NaOH, and I multiplied by E6 divided by 1,000. That's my total milliliters that it took, divided by B6 divided by 1,000, which is the milliliters of hydrochloric acid that it took. You can enter in this calculation any way you see fit. Doesn't really matter. As long as you have something that works on your end, you're more than welcome to do that. So I do all 3, and then the average, well, in that cell I hit equal, average, I type it in, I open my parentheses up, and then I click and drag down the area that I want it to do the average of, and then I hit enter. And that gives me an average molarity of hydrochloric of 0.149. Okay, then I'm going to go through, and this says carbonate standard. We didn't really talk about a carbonate standard, right? And you probably will not do a carbonate standard. You'll just do the antacid standard, or the antacid tablet. So we're going to save you a little bit of work here, and that's okay. Part C is the antacid samples. This is a manual titration. So they did 4 rounds, not 3. Milligrams of antacid that I weighed out, that goes in those lines. They're all around kind of the same amount, give or take a little bit. This one looked a little bit more. That's okay. This is how much I started with as far as NaOH goes. When the titration went from yellow to blue, I stopped recording. There's the milliliters of NaOH that it took at the very end. I subtract those two numbers, and that's how many mils of NaOH that it took altogether. I know the molarity of NaOH, so this is a calculation at this point. Right up here at the top, you're seeing that calculation. This is the molarity of NaOH multiplied by the milliliters divided by 1,000, because I need to multiply by liter there, right? That's why we're dividing by 1,000. I need to convert this over to liter. So that gives me the moles of NaOH. All right, well, this person pipetted 15 milliliters of acid into their antacid flask. So, if I take that many milliliters, convert it over to liter, that's what we're doing here in this step, and we multiply by the concentration of hydrochloric, which I saw from up here from the top, that's F10, right there we are, that will give me the moles of hydrochloric acid. Well, we talked about moles of hydrochloric acid in total, and this is how many moles of NaOH that it took. So to get this number, I'm going to take C39, which is how much I added, minus C37, which is how many moles of NaOH it took, and that gives me my neutralized hydrochloric, 0.00140. Well, I know that that number divides by 2. That gives me the moles of calcium carbonate. I then multiply by the formula weight of calcium carbonate to get milligrams of CaCO3, well, to get gram. Then I multiply by 1,000, look at the formula up here at the top, to get gram or milligram. And then to get percentage of CaCO3, I can then take this number of milligrams divided by the milligram from the very beginning, and that gives me a percentage, 35.1% calcium carbonate. I then take all of those numbers, I average them all up to get an average percent, and I can compare that percentage to my label percent. My label might say 500 milligrams. The average tablet weight might be 1280.2 milligrams. So my percent calcium carbonate label is 39.06. So it looks like this has a little bit less than what my tablet says that it should have. Part D is the titrando run. This basically is just going to print off the reports for you. So milliliters of titrant that it took, your sample size, your percent of CaCO3, that will be printed on the report. And this titrando did a higher average than what's reported on the label. So this gives you an idea of the machine versus hand. And we're not saying that the machine is better every time, but you will figure that out when you do your titration and when you report your data. Part E, comparison of your data versus the titrando. This is something that we do on our end. So do not worry about this number. This is just really for us. So I would look at Part A, hydrochloric acid standardization, and then I would look at Part C. This is all of your tablets and titrating your tablets. And then Part D, everything's done for you. You just have to have a place to put in your actual raw data from the instrument. So no calculations really are done down here on this end. Okay, so that's it for the Excel. Hopefully that will give you an idea of where we're going with this and all of the awful stuff that you've got to prepare for this, which is why we're giving you 3 lab periods to do it. We want you to take your time with the sample preps, take your time with the titration, take your time with the titrando, and we want to give you some time to work on the spreadsheet and ask questions if you have them. So good luck to you all. A lot of stuff, a lot of things going on, but that's why you have a week and a half to to finish this lab.